Caching is often seen as the ultimate performance booster. In a healthy system, your application checks the cache first. If the data is there, it's a cache kit, fast, efficient, and light on resources. The database stays quiet, resting in the background. But this silence is fragile. We rely on time to live, or TTL, to ensure data doesn't stay stale forever. However, what happens when that timer hits 0 for a high-traffic key? Most developers assume the next request will just refresh it. But in a high concurrency environment, the next request isn't just one person. It's thousands of simultaneous requests all reaching the same conclusion at the exact same millisecond. The cache is empty. This is the beginning of the thundering herd, a phenomenon that can turn a minor expiration into a total system outage.
Imagine a viral news article or a top-selling product page. Thousands of users are hitting the cache every second. Then the TTL expires. Suddenly, the cache returns nil. To the application, this is a signal to go fetch fresh data from the source of truth, the database. But because this is happening at scale, the application doesn't just send one request, it sends every single incoming request directly to the database simultaneously. This is the herd charging toward your most expensive resource. The database, which was comfortably handling 0 traffic while the cache was active, is suddenly hit with a massive spike of complex queries. This isn't just a performance dip, it's a structural threat to your infrastructure.
When the herd hits, the database faces 2 major bottlenecks. First, connection limits. Databases have a finite number of worker threads or processes. If 5,000 requests arrive at once, the database spends more time context switching and managing overhead than actually executing queries. Second, CPU and I/O saturation. While the first few requests are trying to calculate the expensive result to put back into the cache, the other 4,997 requests are trying to do the exact same calculation. This redundancy is the killer. The database slows down, response times climb, and eventually the system hits a tipping point where it stops responding entirely. This is why a simple cache expiration can lead to a site-wide 503 service unavailable error. The first line of defense is request collapsing, often implemented with a distributed lock or a local mutex. Instead of letting every request hit the database, the application logic says, if the cache is empty, try to acquire a lock for this key. Only the first request gets the lock and proceeds to query the database. Every other request waits. Once the first request finishes and updates the cache, it releases the lock. The waiting requests then see the fresh data in the cache and return immediately without ever touching the database. In libraries like Go's single flight or Node's promise-based patterns, this effectively turns 10,000 database queries into exactly 1.
Another common cause of the thundering herd is synchronized expiration. If you start your servers and load 1,000 keys into the cache with the exact same 1-hour TTL, they will all expire at the exact same moment an hour later. To fix this, we use Jitter. Instead of a flat 3,600-second TTL, we add a small amount of randomness. One key might expire in 3,580 seconds, another in 3,615. By spreading the expiration times across a small window, we prevent the cliff where traffic falls off the cache and onto the database all at once. This smooths out the load and ensures the database only sees a manageable trickle of refresh requests rather than a tidal wave.
The most sophisticated solution is the soft TTL, or stale while revalidate pattern. Here, we store 2 timestamps in the cache. When the soft TTL expires, the first user who hits the key still gets the stale data immediately, so there's no latency. But the application triggers a background task to refresh the cache. Until that background task finishes, every other user continues to get the stale data. Only when the hard TTL is reached do we actually block and force a refresh. This approach completely decouples user latency from cache maintenance, ensuring that the herd never even hears the database gate open. It's the gold standard for high-scale read-heavy systems.
To summarize, the thundering herd is a race condition at scale. To prevent it, you must control the transition from cache miss to database hit. Use request collapsing to ensure only one worker refreshes the data. Use Jitter to prevent your cache keys from conspiring to expire at once, and consider soft TTLs to keep your users moving fast while your backend updates in the shadows.
Caching isn't just about making things fast, it's about making things stable. By accounting for the herd, you transform a fragile system into a resilient one that can handle the unpredictable nature of internet traffic. Thanks for watching this deep dive into system architecture.